Hi, geometry class. This is the 1.5 notes. And today what you are going to be doing is you're going to get a paper copy of these notes from the teacher. You're going to listen to the video, fill in the notes with the video as you listen along. And when you're finished, show the teacher that you've completed the notes, and then you can work on your homework assignment and big ideas. On this first slide, what I would like for you to do is just look through these vocabulary words. We'll be talking about these vocabulary words in about the next 5 to 10 minutes. And pause the video for a second and just write down either what you think you know the meaning of the word to be, or draw a little diagram that you think would show what the meaning of the word would be. So go ahead, hit pause for just a second and take care of that. All right, so what we're going to look at is angles today. And on this example we have here, we have a diagram of a lighthouse and there's boats out in the ocean. What they want us to do here is to name 3 angles shown in the diagram. Well, something we want to make sure we take note of is that it takes 3 letters in order to name an angle, and you always put the vertex or the corner of the angle in the middle, so it'll be your second letter. So if we look at this, let's think about how we can name it with 3 different ways. Well, you can look that there's a ray coming out of the middle of the angle, which means that's going to break it up into some different pieces. If we look, one angle we can name is the big angle itself, angle JML. And we name angles with the little angle in front, JML. We also could have called this angle We also could have called this angle L. We also could have called this angle L. MJ. That's the big angle. Then, if we look, there's a smaller angle here. That's called angle JMK, which also could be called angle KMJ. And then the third angle we could look at is this other one. That's KML. Then I want you to think about how else you could rewrite that instead of KML, with the vertex in the middle still. Okay, so let's take a look here. Down here it says you can also name an angle using a number labeled inside of the angle, or just the angle itself if the vertex only has a single angle coming out of it. So we could, this number 1 here, name it angle Q. We could also name it angle PQR. The second one, think for a second about how there's a couple different ways that we could name it. There's a little red 1 in there. We could name it angle 1. We could name it angle Y, or we could name it angle XYZ. We could also name it angle ZYX. All of those are referring to the same angle. And on number 3, it's the same idea as on number 2. You could name it by the number, angle 2. You could name it by just the letter E, because there's only one angle there, angle E. And then you could name it with 3 letters like we have previously, angle DEF or angle FED. Okay, some of the vocabulary from that very first slide that we want to make sure that we knew is some vocab about the parts of an angle. Number 1, the vertex. The vertex is just the corner of the angle. Okay, the sides of the angle are the rays that make up your angle. So that in red there, those are the sides. The interior of the angle, that's the part that's on the inside of the angle. That would be anything on the inside. And then the exterior would be anything, any area on the outside of the angle. And hopefully this slide here is a review for you. An acute angle is any angle that's less than 90 degrees. It's between 0 and 90. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180 degrees. And a straight angle looks basically like a straight line, and it always measures exactly 180 degrees. If we look here at the protractor, we're going to actually measure this. And it's asking us to find the measure of different angles and then classifying it. Classifying it means that we are going to say, is it an acute angle, a right angle, an obtuse angle, or a straight angle? So let's find the first angle, GHK. And let's highlight it here. We have GHK. Well, one side of the angle is at 0 degrees. And if we follow that, we can look at it. Just looking at the angle I've highlighted in yellow, we can see that it's going to be an obtuse angle. So we know it should be greater than 90 degrees. And if you look, it goes to approximately between 120 and 130 degrees. It's 125 degrees. If we look at our second angle, angle JHL, you can see it starts on the right-hand side, so we're going to use those numbers on the inside instead of the outside. And we can see it goes from 0 to exactly 90, and if it's 90 degrees, it would be a right angle. And then let's look at our last one, LHK. Angle L, LHK. Well, if you look, that doesn't start on either of the ends, so we need to look at where the two endpoints are. Well, here, it's at 90 degrees. And here, if you look, coming from this side, it would be at approximately 55 degrees. If you look coming from 90 degrees, it's at approximately 125 degrees. Either way, if you find the difference between those two, the difference is 35 degrees. And 35 degrees is an acute angle. Next, we're going to look at angle addition postulate. This is very similar to segment addition postulate. Remember when we added parts of a segment together, it was the little part plus the little part equaled the whole. Angles work the same way. You can take the two small angles on the inside, and it's going to equal the whole. So if we took this little angle, angle RSP, and added it to angle PST, it's going to equal the whole thing. Okay, so if we look at our angle here, we're just going to set up and solve some equations. It says given that angle LKN is 145 degrees, so LKN is the whole angle, so both parts together are 145 degrees. Find LKM and MKN. That just means find the two smaller angles. So to do that, we know we can use the angle addition postulate. We can add the two angles together. So we'd add 2x plus 10, that's the first small angle, plus 4x minus 3, and it equals the whole thing, which was 145 degrees. If we solve that just using our regular algebra rules, we can combine our like terms. And we get 6x plus 7 equals 145. If we subtract 7 from both sides, we get 6x equals 138. If we divide both sides by 6, we get 23. So x equals 23. But it's asking what are the measures of the angles. So we need to take x out and put 23 in its place. So we'll go back up to the first angle, and we will say if x is 23, 2 times 23 is 46, plus 10 is 56 degrees. And then 4 times 23 is 92, minus 3 is 89. And if we double check that, if we say 89 plus 56, we had better get 145, which we do. Okay, so if we look at these, one of those vocab words from that first page was a straight angle. So in our mind, we should be saying, oh, a straight angle would add up to 180 degrees. So this equation, we're actually going to set up as 10x minus 5 plus 4x plus 3. And when we add those together, since it's a straight angle, it will equal 180 degrees. Then we can combine our like terms, and we can go ahead and figure out what x is. Once we know what x equals, Then we can go back and figure out what each angle measure is. I'm going to let you go back and do that on your own, just like we did on the last slide. And similarly, this one, we have a right angle. If the angle is a right angle, the two parts are going to add to equal 90. So we would have 2x plus 2 plus the other angle, which is x plus 1, is going to equal 90 degrees. And again, just like on our last problem and on our last slide, you can go ahead, solve for x. Once you know what x is, you put it back into each part and figure out what the two angles are. And if you did it correctly, these two should add up to 90. The first problem, the two angles you get should add up to 180. And then the last thing that we're going to talk about today is an angle bisector. An angle bisector is a lot like a segment bisector in the fact that instead of a segment bisector splitting the segment in half, an angle bisector splits the angle in half, which means it's two parts that are equal to each other. So if we have this diagram here, we have angle, let's see, it says ray QS bisects angle PQR, and the measure of angle PQS is 24 degrees. Find the measure of angle PQR. Well, first thing we want to do is draw and label a sketch first. That always helps. So we have our big angle, and I don't know exactly how big it is, but I'm just going to draw it like that. We have PQR, and it says QS, so I have a ray coming out of here, QS bisects it. So we know that these two angles here, this angle and this angle, are going to be the same. They are going to equal each other. So let's see what else it tells us. It says the measure of angle PQS is 24 degrees. So I know that this angle is 24 degrees. It says find the measure of angle PQR. PQR. Well, that's the whole angle. Well, if I know that part of the angle is 24 degrees and it bisects it, that also means this one is also 24 degrees, which means the whole angle is going to be 48 degrees. Sometimes on your homework and stuff, it will have problems where instead of this being 24 degrees or something like that, it'll have two algebraic expressions. For instance, if you had an angle bisector and this was 4x minus 8 and this was 3x plus 2, let's say, if this is an angle bisector, you would set these two equal to each other to find x. Okay, and good luck. Your homework is in Big Ideas. Make sure that you check in with your teacher with your notes to make sure that you're ready for your Big Ideas homework, and good luck.